I'm Agnieszka Niemark, and this is the Boyce Thompson Institute Centennial Oral History Project. It's April 22nd, 2023. My interviewee today is Bob Kohut. Bob joined BTI in 1980 as a research associate in the environmental biology program, and he worked at BTI as scientist until 2004. We are recording this interview at the Boyce Thompson Institute in Ithaca, upstate New York. Bob, thank you so much for joining this project.
Well, it's my pleasure to help out and celebrate the anniversary of the Institute.
That's great. Thank you. I would like to start the interview with you telling us a little bit about yourself, about your background, and why you decided to study forestry out of all the disciplines. Tell us just about the beginnings of your studies.
Well, I was born and raised in Pennsylvania, the southwest part of the state, a pretty rural area. Spent a lot of my free time out in the fields, woods, hanging around creeks. And I had kind of decided that whatever I did for a living, I wanted to be outdoors for the most part. I didn't want to wear a tie. I didn't want to live in a city. And so, to my logic at that time, maybe I should try forestry. Well, I was not the best student possible in high school. I spent too much time reading about the outdoors and being outdoors and doing things like that. And so I ended up in the third, fifth of my high school class, which today would be like the kiss of death. It's not very good. But quite by accident, I had applied to Penn State University forestry program, and all the freshman foresters at that time, they went to a campus in south central Pennsylvania, a town called Mont Alto. And it was only years later, when I kind of reflected back on my life a little bit, that I came to understand why I got into college at all. And that was that they had 160 beds there. At that time, it was all guys. And so they were going to fill each of those beds. Well, I was probably like 158 or 159 out of that 160, and I was very, very fortunate to get into college. Once I got in and was there and realized, okay, now I better start applying myself. I always had the capability. I just didn't have the will to bend to meet the demands of education. And so I did really well. I mean, I went up to the main campus for the rest of my career. And 3 years later, I got a bachelor's degree. During that time period, though, I was exposed to a really charismatic professor, Dr. F.A. Wood. He was a forest pathologist, and he taught two classes, introductory forest pathology and advanced forest pathology. I took them both from this guy. He made a lasting impression on me, not only because of the kind of person he was, but the way he taught and even the subject material. I really got into it. So I had kind of thought, oh, gee, maybe sometime in the future I would come back and do a graduate degree with him. Meanwhile, my very best friend, a guy named Bill Hartman, and I were hanging around. This was in October of our senior year, and we were going through the student union, and it's all crowded with people and everything. And lo and behold, I look across there and I see this big poster with airplanes and ships on it. I say to Bill, let's go over and take a look at this. So we wander over through the people, and we're over there, and it's a recruiting team for the United States Navy looking for candidates to go to officer candidate school in Newport, Rhode Island. So Bill and I, like in an hour, we sign up to join the Navy and to go down and to take our physicals. And so that we didn't have to show up until the following October. So we had a whole year. And it was really great. Didn't have to look for a job, and could do something over the summer that we liked to do, knowing that come October, we're going to OCS, man. And it was great.
Okay, so that means your study were interrupted at that point, right? Could you tell us, Bob, a little bit about the experience in the Navy on the aircrafts? What happened in the next few years?
Spent 4 years. I got a commission as an ensign in the Navy. Spent 4 years on an aircraft carrier. Probably one of the most significant experiences of my entire life. As an officer, you have to learn how to accept and manage people and handle responsibilities. I stood watches mainly on the navigation bridge, a 3-officer watch team up there. I started as the lowest of the 3, and then over a period of 2 years, you work your way up through the watch team. At each promotion, you have to take written and oral exams, and the captain has to approve your promotion until finally about 2 years later, I qualified to stand officer of the deck watches underway, which when you're in that position and you're holding that watch, the only person on the ship who has seniority to you is the captain. You're responsible for everything. You're responsible for 700 feet of ship to start with, navigating it safely and make sure that you know where you're going, you don't hit anything unintended. To take care of the men, be responsible for the aircraft that you're flying and launching. And, it was really a very important experience for me to learn how to handle all those responsibilities. I was about 24 years old at the time. So, it was important to me.
So it looks like it was a quite challenging experience, and I would say so much out of this nature-loving person that you just described. So what happened? Like, what you decided, after a few years?
Well, I really liked being in the Navy, and I thought really seriously about staying in and making a career in the Navy. There came a time when I had to make a decision: stay in or get out. And so I sent a letter. This was back in the days when you had to use the mail to communicate. I sent a letter to Dr. F.A. Wood and just asked him a simple question. Do you have any graduate student openings? And would you consider me for one of the positions if you had one? He said, "Oh yeah, sure." He said, take the graduate record exam and submit your application, and we'll see what we can do for you. So, all right, I had to take the GRE. So they flew it out to the ship. They put it in a safe. They locked it. On the day and hour of the exam, another officer opened the safe, got the exam out, gave it to me. I took it, put it back in the safe, locked it back in. Eventually, they flew it off the ship back to land where it was evaluated. And the upshot of all of it was that I got out of the Navy and spent about 4 months at home and then started at Penn State in the fall.
So just for the record, Bob, I wanted to mention that we are talking about late 60s, right? Around 69, you move for your graduate studies back to Penn University. And could you tell us a little bit more about the time when you were doing your graduate studies? What kind of decisions you made about the specialization, in which field? Talk about your main interest and give us a sense of the things happening in the early 70s when you were at Penn State.
Yeah, I started, F.A. Wood had a research project that hadn't been worked on for a couple of years, but he had some things he wanted me to finish up. It was a disease of sugar maple. And so I started working on this sugar maple project, spent a lot of time in the field trying to find diseased sugar maple trees. Couldn't find a single tree. Somehow, between the last time that it had been worked on and the time that I tried to work on it, the disease has sort of resolved itself. So I talked to F.A. Wood about this problem, and he says, well, look, I'm doing some work on air pollution. I'm beginning to look at the effects of ozone on trees. He said, would you be interested in doing that? I said, darn straight I'd be interested in doing that. I had developed an interest in environmental issues, and I knew he was doing this. I didn't know that he had an opening that I might be able to fill. But when he made the offer, I grabbed it. And so I started working on the effects of ozone on trees. A tree that was the model that we were working with was a hybrid poplar. So started working on my master's degree with that. And then later, when I finished my master's degree, I started working on another problem, looking at the interaction of two oxidant air pollutants, ozone, and one shortened as PAN, peroxyacetyl nitrate. And so that was the research project that I worked on for my PhD. Along the way, I also served as a teaching assistant to F.A. Wood in introductory and advanced forest pathology. And somehow, and I don't recall exactly how this happened, but one of the forestry guys in these two classes was a guy named John Lawrence. And somehow we hit it off. I don't know. We started just talking, and we kind of became friends. And I was a TA in a class in introductory and a TA in a class in advanced, and John was in both of those classes. So he and I became friends at Penn State. And as time went on, he finished up his undergraduate degree, and he decided to go to the University of Minnesota to pursue a graduate program. Just about the time that I was finishing my PhD, Dr. F.A. Wood decides he was going to go to the University of Minnesota in plant pathology as the head of the plant path department. So he takes off, and he's up there. I finish up my PhD, and I'm looking around for a postdoc. And I got two offers. One at USDA lab in Raleigh, North Carolina, and the other, the University of Minnesota. So, and I'll be honest about this, I actually accepted the North Carolina postdoc. And after I did that, within about 2 days, I came to the realization that I just couldn't go to North Carolina. It was just too far out of my home range. I couldn't do that. So I called them back up and explained to the people, and I knew these people. And they knew me, because all the air pollution researchers participated in something called Air Pollution Workshop, which was a very informal get-together, annual get-together of people doing this kind of air pollution work. And you got to know everybody, whether they were PhD project leaders, or whether they were technicians, or whether they were graduate students or undergrads, if they were involved and they went to the meeting, you got to meet them. So I knew these guys down at NC State. And when I called and said, sorry, guys, I can't come, they sort of understood because they knew me. And I headed off to Minnesota. And so I go up there. There's F.A. Wood. There's my old buddy, John Lawrence.
Let me stop you here for a moment just to talk a little bit more about the air pollution workshops and what was happening in the 70s in general. So I heard from Luke Colavito that BTI also started to organize some air pollution workshops in the late 60s already at BTI. I'm wondering, Bob, if at the time of your PhD studies and postdoc, did you hear about BTI at all? Did you know about their research? Were they part of the network you are talking about, this early network of few institutions? Or at the time it was sort of an institute apart, not, institution that among other colleges. Do you remember that?
The core group of people who were researchers at Boyce Thompson Institute at the time were devoting a lot of their attention to the impacts of hydrogen fluoride on plants. And they were regular attendees at the workshop. In fact, the workshop, over its lifespan, was hosted by the Institute a couple of times. And so, yeah, I knew these people. And I knew their focus was mainly on hydrogen fluoride. In fact, this was the world center of research on hydrogen fluoride research. So, I knew them, and I knew people from other places also. So it was a really cool meeting because it had no formal substance. I mean, there was no agency backing it. It was just something that the group of researchers had cobbed together that we would meet at somebody's research site on an annual basis. And
what were the main concerns at the time? Which air pollutants were discussed mostly in the 70s?
Well, I would say that the main thing that was coming on was ozone. And ozone was ubiquitous. I mean, wherever you had automobiles, you ended up with ozone. And for the most part, it was California, Southern California. A lot of cars, a lot of solar radiation, which is involved in the photochemical generation of ozone in the atmosphere. So ozone was the big problem. And in Southern California, it was impacting agriculture. It was also impacting trees to the east of the LA basin. So it was coming on. The other things were mainly air pollutants that came from industries that were scattered in the Ohio River Valley and other places around the United States.
And I think both you and Luke Colavito mentioned studies of tobacco plants in relation to one of the pollutants, but I don't remember if it was the fluoride or something else, because apparently the tobacco plant was very sensitive, to pollution.
The tobacco problem is kind of interesting because that was mainly located in Connecticut. You don't usually think of Connecticut as being a big tobacco state, but the tobacco that they grew and harvested there was used to roll cigars. So it was the outer wrapping on a cigar, which meant that it had to be blemish-free. If you wanted to get the top price for your tobacco leaves, you had to have beautiful-looking leaves. And ozone would put, at a minimum, spots on these leaves, and sometimes would actually do more damage than that to the leaves. So they were losing market. I mean, some of the stuff they couldn't sell, and the stuff they did sell was sold at a discount. And it's also interesting that these plants were so sensitive to ozone that it was not just the ozone being generated from automobile exhaust, but ozone is also produced when a bolt of lightning passes through the atmosphere. That lightning splits O2, and when those individual atoms join back up, sometimes they join up to form O3, which is ozone. And this tobacco, this leaf roll tobacco, is so sensitive to ozone that a bad lightning storm would produce enough ozone to injure the plant leaves. So you can imagine that if you had more ozone being produced on a long-term basis in the atmosphere, that these leaves were being hit pretty hard. So there was an economic impact there. There was also, of course, a lot of injury to agriculture in California also, but no one quite knew how bad that was. I mean, what was the economic damage being done there? Well, no one quite understood that.
We will talk about that in a moment, Bob, about the ozone becoming also a main concern for crops. But I just wanted to go back for a moment to your postdoc studies and your decision about the first job after finishing your postdoctoral studies. You mentioned to me that John Lawrence, at some point after his studies, decided to join BTI, but you made a different decision, right? Tell us about your environmental work before BTI.
When John was at Minnesota and I was at Minnesota, we spent a lot of time together. We worked on a couple of field projects together. And so, that acquaintance, as well as the fact that we worked on a project for the National Park Service at a place called Indiana Dunes National Lakeshore, which was in Indiana. And so we would have to drive from the Twin Cities down to Indiana. And so, it's like, 5-6 hours. You do a lot of talking with whoever you're riding with over 5 or 6 hours. We got to know each other very well and became really good friends. And then John, after he got his PhD, came to Boyce Thompson Institute. They were down in Yonkers at the time. I'd worked for the Forest Service for a couple of summers in Wyoming, and I spent another summer with Forest Service in the Marble Mountain Wilderness area in California. I liked the West. I liked that big sky, big mountains, big rivers stuff. And so I sent out a bunch of letters just blindly to consulting companies, environmental consulting companies in the Rocky Mountain states. I got a response back from one in Fort Collins, Colorado. They were interested in me because I had been doing air pollution research work. They did work writing assessments of potential environmental impacts, and they thought I could make a contribution to what they were doing. So I left Minnesota and went to Fort Collins, Colorado, working for these guys. And for me, that was like earning another bachelor's degree. I learned so much there. Learned how to write proposals. I learned how to develop a budget, learned how to manage people, learned how to manage money, saw how my interest in air pollution tried to fit into this environmental assessment issue. And I came to the realization that there was almost no research that had been done that was looking at impacts of air pollution in a quantitative way in the field. It was all observational, and there wasn't much of an understanding about how much ozone was in the air or how much sulfur dioxide was in the air to produce an injury on a plant, or how much a plant could tolerate without being injured. So there was almost none of this dose response information that you need to do these kinds of assessments. So I was out there for 4 years, and during that time, of course, I was still going to the air pollution workshops that were being held around the country, and I saw my buddy John, and he was at BTI, which was down in Yonkers at the time. And so I'm out there in Colorado one day, and the phone rings. And I answer the phone, and it's my buddy John. And he says to me, the Institute is going to start a new research program. It's going to be funded by the EPA, and it's going to look at the response of agricultural crops to controlled levels of ozone in the field. Are you interested? Yeah, I'm interested, man. So I they had moved up to Ithaca. I came to Ithaca. I interviewed with Len Weinstein, and I got a job offer.
We should mention here that Leonard Weinstein was leading the environmental program at the time. And we are talking about 1980, more or less.
It was 1980,
yeah.
That's correct.
Could you tell us a little bit more about the origins of the crop loss assessment network? How the program started and who was involved in this network research?
As I said a moment ago, trying to develop an impact assessment on ozone or sulfur dioxide at that point in time was not a very fruitful exercise because you didn't have the quantitative relationships between how much was in the air and what that did to the plants. So you could only say that, there's the potential for something to happen. But EPA was interested in establishing a national ambient air quality standard for ozone. And they have two standards, actually, one for health and one for plants, animals, materials. And so this was the one that was going to look at part of the plant problem. The idea was that they would establish something called National Crop Loss Assessment Network, or NCLAN. And NCLAN would have research conducted at multiple locations around the country. Boyce Thompson Institute in Ithaca represented the Northeast. My buddies down in North Carolina were going to represent the Southeast. Argonne National Laboratory near Chicago, the Midwest. Oregon State in Corvallis was going to represent the Northwest, and the University of California, Riverside, was going to represent the Southwest. So the objective and the idea was that each of these sites would grow crops that were common to their area, expose them to controlled levels of ozone for a growing season, and then tabulate that ozone data to find out exactly how much ozone the crops had received, and harvest whatever the crop was to see what the impact was. And each year, each crop was to receive multiple levels of ozone, from charcoal filtered air in which ozone was actually taken out of the ambient air. So that was a treatment that was less than ambient ozone, a treatment that was equal to ambient ozone, and then at least 2 treatments where you added ozone to the exposure chambers. And these exposures were conducted in these large circular chambers, 10 feet in diameter, 8 feet tall. And so you could control the ozone environment in there, and then develop these dose response functions so that for ozone in particular, you would be able to go to the field after you monitored ozone. If you knew the crop that was growing there, be able to make some assessment of the potential for injury and crop loss based upon the NCLAN research.
And Bob, this kind of open-top chamber studies for the Northeast, were they conducted mostly in the Ithaca's area, or did you build the chambers somewhere on the plots in the state, in different places?
No, they were all done here in Ithaca. We had a farm site not too far from where we're located right here. And we actually had our own farm manager, our own tractors, our own field preparation equipment. And so we would manage the crop, if you will, exactly like a farmer would. And the crops we looked at over the course of the study were red kidney beans, soybeans, winter wheat, and forage, a combination of timothy and red clover. Most of these crops were done for more than 1 year so that you would have a repetition in time also. As the environmental conditions changed, it might change the ability of the crop to pick up the ozone in the treatment. So you wanted to see what the variability might be from year to year. So it was really a nice study. It was conducted on a national level. All these data were then used in a loss assessment that was conducted by some people who were economists and mathematicians. And so the EPA not only got the dose response information out of this, but they actually got an estimate of what the national loss in these crops might be over the United States.
Yeah. So this project was going on between 1980 and 1986, more or less. And I think you told me that soon after EPA was able to establish the first limits or standards related to ozone. And that was done because the data was collected on sort of regular basis and analyzed straight after that. Could you tell us, Bob, a little bit more about particular role that BTI play in this project? So you mentioned the open-top chamber studies. I have seen that also another method was mentioned in the annual reports called zonal air pollution system. Could you explain the differences between these two? And also that it was mostly done in the field, like that was, the BTI was doing field studies on this project, right? That was the...
Right. All of this work in NCLAN was done in the field. And the ozone studies were done the way I just described them. There was also a series of exposures. I was not directly involved with this. A series of exposures that using a system called the ZAPS, Zonal Air Pollution System, which actually was performed by releasing sulfur dioxide directly into the atmosphere and allowing it to drift over a field of whatever the crop was that you were interested in. Then the sulfur dioxide concentrations were measured at various distances downwind, and of course the further away you got from where you released the SO2, the lower the sulfur dioxide concentration was. So that's the zonal part.
Was that Amundsen that was leading this project, which combined studies of sulfur dioxide and ozone? I think Amundsen at some point, like the NCLAN study was a little bit expanded because additional funding was added to it for this combined stresses studies.
Right. There was a little bit of work done to try to take a look at the combined effects of those two pollutants. That was not the main thrust, though, of the NCLAN study. It was mainly ozone work.
But did you mention that led to the next studies that BTI undertook in this area, which was called Response of Plants to Interacting Stresses, ROPIS project? Was
right. Between the time that we did the bulk of the work on NCLAN and between the time we started what was called ROPIS, Response of Plants to Interacting Stress, we did a piece of R&D work, basically. There was going to be a coal-fired power plant built to the west of us along the shore of Lake Ontario, and it was going to be built near the grape growing area of the lake. There was a lot of concern about whether or not sulfur dioxide emissions from that facility were going to impact grapes. And so we thought, maybe we can do some exposure work, some controlled exposure work actually on site using a real operating vineyard and do controlled sulfur dioxide exposures. So what that led to was us building these super chambers. Remember I told you that the ones we used for NCLAN were round, 10 feet in diameter, 8 feet tall. The ones that we built and tested on grapevines were 10 feet wide and 24 feet long. They were rectangular. They were about 12 feet tall. And the idea was one of these chambers would be put over a section of grapes on the grape arbors. And then we could introduce sulfur dioxide into the chambers, and we could look at how the grapes responded, what the injury was, what the productivity was, and maybe even look at the sugar content of the grapes and other kinds of quality issues that are of interest to people either making grape juice or making wine. So we spent a couple of years developing these chambers, actually testing them in a wind tunnel here at Cornell to see how well the model worked, and because he wanted to exclude ambient air while having good distribution of the pollutant that we're putting into the chambers.
But you didn't install them in the western New York State. They were built here, right, in Ithaca, and you kept them here?
No.
Or did you?
We actually tested them over some grapes in a vineyard along the shores. We tested them, and they seemed to work fine. So we were kind of gearing up to do these SO2 studies in this vineyard when, lo and behold, the utility decided they're not going to build the power plant. So, it's like turning out a light switch. Suddenly you're geared up to do something, and then, no, you're not going to do anything. So we took the chambers, and they were so, I forgot to say this, they were so big that, and so awkward, you couldn't build them over the line of grapes. You would destroy the grapes just in the process of climbing around and building these things. So you built them off to the side, and then you moved them onto the grapes. Well, they were so big that we needed to have a helicopter lift the thing up and put it over the grape arbor. But we did dismantle them all, and we brought them back to Ithaca. And so now we've got these chambers that need something to do. And so that's when we came up with response of plants to interacting stress. And this was at the time when there was a lot of concern, rightly so, about acidification of precipitation from sulfur dioxide and nitrogen dioxide, leading to the production of sulfuric acid and nitric acid, both in rain and in particles. And it turned out that in certain parts of the Adirondacks and elsewhere in the Northeast, red spruce were declining. And there was a lot of concern that maybe that decline was being driven by acid deposition. Either acid deposition having an impact on the foliage of these trees, or acid deposition having an impact on the chemistry of the soil and an indirect effect on the trees. So we had the hardware. We just needed the project. And this is where this responsive plants to interacting stress developed. And it was a big project. A big project that involved us getting funding from the Electric Power Research Institute, from the
Empire State Electric Resource Corporation as well, I think.
Right, the Electric Power Research Institute, which is the one in California, NYSERDA here in New York, Niagara Mohawk, the Forest Service threw some money into this also. And so we ended up designing a 5, which ended up being a 6-year study, about $3.8 million. And so we needed some trees to work with. Red spruce, of course, were the species of interest. And we thought we needed to get them from a place where we felt pretty certain they hadn't been impacted yet. So we went up to Maine, north central Maine. We took a bunch of technicians and project leaders from the Institute, went up there, and we actually dug up, I think we dug up maybe a couple hundred red spruce trees, about 1 meter to 1.5 meters tall. We dug them up so they'd be on their own soil profile, their own root mass soil profile, and put them into these 1 meter diameter pots. Loaded them into an 18-wheeler and had them driven down to Ithaca overnight, where we had a team of people down here to unload them. And we did that until we had all the trees down here. Then we kept them for 1 year to see how well they were going to adjust to being in these pots, to make sure that they all lived, or as many of them lived as we needed. And meanwhile, we were developing the site for the experiment. Now, because we were interested in looking at response to the tree, response to the soil profile, and we had these big chambers, we put 6 trees in each of these chambers, divided the chamber into 3 10-foot, I think it was 10-foot sections, and we put the pots into the ground one of the two pots in each of these sections was on a weighing lysimeter. We're weighing the pot. We're weighing the soil. We're weighing the tree. Okay, you're probably wondering, well, why do you want to do that? Because each of these sections is going to get a different acid rain treatment. And so we need to know how much rain we put on it. We can tell that by weighing the tree, weighing the soil. We also are able to sample the water as it percolates through the pot at 3 different levels in the soil profile, so we can see what the changes in soil water chemistry are. And after we have these trees in there for a year, 2, 3 years, 4 years, you can actually see the tree putting on weight, so to speak, or growing, because we're weighing the soil and the tree. The soil isn't going to change weight very much, but the tree may. So we're doing all this work, and the idea is to determine whether or not the 3 different pH treatments we have and the 4 different ozone treatments we have are interactive. Do they impact the tree alone? And are there any interactions that take place here? So it's a great project.
So it looks like over the years you gain more and more experience in analyzing ozone in different ways, right? And ozone's effect on first crops, then plants. So that led at some point to another project which was done in Maine, I guess with already first contacts established there, in the park, natural park called Acadia. So this project started a little bit later, Bob. That ROPIS was done between 86 and 91, and Acadia started in 91, soon after. Could you connect the both and briefly tell us about Acadia?
Yeah, Acadia was, well, first of all, you might want to ask the question, Acadia is pretty remote. Is there an ozone problem in Acadia? And the fact is, yes, there is, because over the summer, usually there's a high pressure system sitting off the coast of the U.S., the Bermuda High, and it moves air from all the way down in the Washington, D.C. area, up along the coast, through Philadelphia, New York City, Boston, across the Gulf of Maine to make landfall at Acadia. So some of the highest ozone concentrations on the East Coast were occurring in Acadia. And having done, this work, there was some interest in us, on the part of the Park Service, us taking a look at what might be going on in Acadia. And it was an interesting project in that we, here at the Institute, worked with 2 people from the University of New Hampshire, Bob Eckert and Tom Lee. Bob was basically a physiologist, and Tom Lee a botanist. And so they helped us when we set up our regular round open-top chambers up in Acadia, because what we did is all the plants that we exposed to ozone in these chambers were grown from either seed or cuttings or root sections from plants in the park. So we used the same genotypes that were found right on site. And again, it was a study where we used multiple levels of ozone, and we took a look at the responses of the plants to determine which plants were sensitive, what the symptoms looked like, and basically how much ozone was required to do it. Was it ambient level, or did we have to add ozone above ambient? So where did these plant species sit on the spectrum of sensitivity, and what did the symptoms look like? So we did this for about 3 years, and then that information was taken to the field. Along with Park Service people, we went into the field and looked at these species that were identified as being sensitive so that we could determine, yes, they were being injured in the field, or no, they weren't being. And also we trained the Park Service people up to take a look on their own so that they could do these assessments by themselves.
So I understand that helped to establish the first surveys which identified particular species, right, and effects of ozone.
Right.
Okay, Bob. So I would like to talk for a few minutes because we are already quite, up on our time. But if you could say a few words about the project in Alaska, because that's a quite remote area. How come BTI involved in the plant studies, environmental studies in Alaska?
I'm not exactly certain how we got connected to the oil and gas industry in Alaska. I think it might have been through the aluminum manufacturing people, that maybe there was some crosstalk there. But the people in the Prudhoe Bay oil fields were being sort of pressed by the state of Alaska to assess what the impacts, the air quality impacts, might be on tundra vegetation. And one of the things about tundra vegetation is that it's normally, those plants grow on normally nitrogen-poor soils. And there is a facility up in the oil field there in Prudhoe Bay where they extract natural gas from the oil gas mix, and then they compress that and they re-inject it back into the oil field. And they do that because they don't want to flare all that gas. They don't have a gas pipeline to ship it out of there. And they use that compressed natural gas to actually drive oil through the rock strata to places where there are wells so it can be extracted. But that's the place that burns the most natural gas in the oil field. They also use it to generate electricity at a couple of locations, but they burn a lot of natural gas to compress natural gas. So they are emitting oxides of nitrogen into the atmosphere, and that is being deposited on tundra. So the question arose at some level in the state, what's this doing to the plants? So Bob Amundsen, John Lawrence, and I, along with Paul King and Rich Raba, two great technicians, spent a couple of summers up there, a couple of weeks at a time, and Bob's wife also, Joy Belsky, looking at differences or looking for differences along a deposition gradient of nitrogen away from this compression plant. And we had permanent vegetation plots we established there. We would go back and assess the number of plants, the condition of the plants, and take samples of leaf tissue and soil and do analyses to see whether or not the plant's species composition was changing along this deposition gradient. Long story short, no impacts.
Yeah, you mentioned to me that you didn't find any significant effects. I just wanted to maybe mention here that the project was sponsored both by the industry related to oil and gas, Alaska Oil and Gas Association, but also by the Alaska Department of Natural Resources. Right. So they wanted to know what is happening, and Alaska Science and Technology Foundation. Could you just tell us quickly about your lodging in remote Dead Horse place? What was that about?
The people who up at Prudhoe Bay say no one comes to Prudhoe Bay unless you're going to work there. There's not anything noteworthy there except the oil field. And so we would fly into Dead Horse, which is actually the name of the town, and the Dead Horse Airport, which is actually the name of the airport, and stay in either one of the little motels there, or we would lodge, if they had space for us, in the field, at like the ARCO facility or something. like that. We stayed at this one place called the Seawater Treatment Plant, which is at the end of a man-made spit of land, and it's a place where they, as it just says, they take in seawater, they clean it up, they then pipe it onto shore, and they use that also to drive oil through the rock strata. So this is like about maybe 2 miles or so out into the Beaufort Sea, and we got up there and we thought, oh man, this may not be the end of the earth, but you can see it from out there at the Seawater Treatment Plant. So we go out there, and it's like a first-class hotel for the poor people who have to be out there. I mean, they've got a chef there who's a graduate of a culinary arts school in New York City, and the food is whatever you want. I mean, you just tell him what you want for breakfast, and you got it. And if you're going to be gone all day, he'll ask you, what do you want for dinner tonight? How many crabs do you want? How many steaks do you want? How many steaks and crabs do you want? I mean, it was like a great place to lodge.
Yes, so all this sounds like fun projects that you were doing in the late 1980s and early 1990s. But I'm wondering, how did you find time, Bob, to take up also on the position of the BTI Director of Operations in 1991? You told me that you always wanted to continue your research, but you also agreed to deal with some management issues. Can you tell us about that?
Yeah, well, I had the opportunity to assume a management position when Dwayne Torgerson retired. And Ralph Hardy was the president of the Institute at that time, and he asked me if I wanted Ralph's job. And I said to him, no, I don't want Ralph's job, but I will be willing to sit down with you, and the two of us define what the Institute really needs in terms of management right now. The Institute had just gone through a unionization attempt, and I was not in management at that time. I was just, a scientist, but I was interested in what was going on. And I made a real effort to try to convince people to vote no on unionization. And unionization lost by 1 vote. So I think it was because of that Ralph thought maybe I had something to contribute to the Institute outside of science. And so I sat down with him and we hashed out a job description for me. One of the things that I was interested in was to get something which I called a Management Advisory Committee established at the Institute. And it basically was a committee comprised of representatives of each of the working groups at the Institute, the scientists, management, the technicians, the business office, support staff, so that they had an elected representative on this committee, and the committee would meet once a month, and if there were issues that needed to be dealt with that were the same issues that prompted this unionization effort, that we would know them and we could start to work on them. So I did that, along with just being a part of the 3-man management team of Ralph, John Dentes, and myself. And then I hired Ann Zintak, and she and I worked on the HR responsibilities at the Institute.
So these efforts were probably quite important, to establish some forums for discussion, because Ralph Hardy is well known for reforming the Institute at many levels when it comes to the programs, to how to select and keep faculty or scientific staff at BTI. So it was the time of multiple changes and reforms, right?
Yeah, there was a lot going on at that time, and I really enjoyed that. I had a 70% management responsibility and 30% in research, which allowed me to keep, one leg in both of those realms. I had been here for 10 years, so people knew me, they trusted me, and that was particularly useful in the HR responsibilities, I think. So, I enjoyed that job.
Would you like to talk a little bit more about the social aspect of your work? What kind of friendships you established and relations that you had with your colleagues here at BTI and in these remote locations? That would be interesting.
Well, environmental biology was a special group in that it was composed of scientists and technicians who had worked together for a long time. Everybody worked on every other project. I mean, it was really interactive, and so it was a good group to be in. It was unlike any other program in the institute in that, there was not much ownership of stuff. Leonard was the program director. He was a great guy. I've always felt beholden to Leonard. Unfortunately, he's passed away, but I always felt beholden to him as having given me the opportunity to come to the Institute, as well as John Lawrence for calling me that day and asked me if I was interested. So I feel really fortunate having had this opportunity to work at BTI. It's a great place. Environmental biology was a great place.
If I can just add here that Leonard Weinstein was leading the program until 1992 when he retired, and then John Lawrence took over as program director. Could you tell us, Bob, at the end, how the program was changing over the years? Because I understand that you joined BTI during the golden years, the best years, 70s and 80s, when the program was one of the strongest programs at BTI. What happened later on in the 1990s when climate change concerns became more relevant, and in general, what happened with the program in the late 1990s?
Well, I had spent my time here working most closely with John Lawrence, Bob Amundsen, Lou Coladito, Paul King, Rich Reba, who unfortunately has passed away. Things change over time. When Ralph Hardy retired and Charlie Arntzen came in, Charlie had a different vision of the Institute. He was a molecular biologist, and it was difficult for him to understand what environmental biology was about, what its value was. And so he saw himself as being the person who was going to lead the Institute into the future, molecular biology, and he saw environmental biology as being the past. To some extent, I have to admit that a lot of the environmental air quality problems had been addressed. And there was plenty of data on, what you needed to establish ambient air quality standards for pollutants. And acid rain issue had been addressed. So, to some extent, yes. But that was, that's simply a maturation process. So there were other things like climate change coming along that needed attention, but they weren't on Charlie's list of what he saw the Institute being in the future. And so the first thing he did was dissolve the program structure. So the program directors were disempowered. And then one by one, the environmental biology staff, both the scientists and the technicians, drifted away. Many of them retired. They'd been here long enough to retire. And the program, faded away. Bob Amundsen and I think, were the last ones here. I was able to do some additional work for the National Park Service. When we finished up the program at Acadia, I had written sort of a handbook for the people in the park as to how to do the field surveys. The people in Denver, in the air quality office there, saw this and thought maybe that could be expanded. And so they asked me to write a more detailed handbook on how to do field surveys. And then they wanted that handbook tested at a couple of parks. So I spent my last years here working on those projects for the Park Service. And it did end up in this, I have to admit, a pretty decent handbook that has been used in many parks as a guideline for how to do an ozone field survey and how to set up the plots, the kinds of surveys you can do, how you look at what the ozone injury looks like. And so that was pretty much the last hurrah for me here.
But overall, it looks like you joined the Institute at the right time, at least for the ozone studies, your main preoccupation. It was an exciting time with the big projects that were.
It was. I mean, we did a lot of really meaningful research. And, when I think back to the beginning, when I said I didn't want to wear a tie, I wanted to work outside, 95% of the research I did was outdoor stuff, here in Ithaca or elsewhere. When I was in management, no tie. Bob never wore a tie. If Bob had a tie on, it meant something big was happening. So, yeah, I mean, I feel that I've been really blessed having the opportunity to do the kinds of things I wanted to do as a kid, and knowing the people that I knew and was able to work with. I've been very fortunate.
Thank you, Bob. I think we're going to stop here. Thank you for your
You're welcome.
participation.